Today we'll look at statistical analysis. If you look at this diagram depicts the process of statistical reasoning. Let us say this is the entire population. So probability concept will be applied to the samples. And to these samples, descriptive analytics or statistics can be applied. And from the sample, inferences of statistics can be drawn for the entire population. So what is the meaning of this? Probability theory describes what properties a sample should have given the property of the entire population. So given is the entire population and properties are for the sample. That is probability theory. So what is inferential statistics? Okay. So given the sample, the properties of the sample, we are deriving the properties of the population. This is the difference between probability theory and statistical inference. Now, what are statistical distributions? So they have few properties like they describe shapes of frequency distributions. They can be described mathematically using closed form expressions with very few parameters. Statistical distributions, once abstracted from the specific data observations, they become probability distributions worthy of independent study. Now, what are the examples of statistical distribution? Say, for example, I took this example from qmat.com. You see here heights in centimeter of 30 girls in class 9th. So these are heights in centimeter, 140, 140 like that. Say for example, there is somewhere here 138. 138 centimeters is the height of a girl, let us say. Now, similarly, 138 is again here. So there are two girls whose heights are 138. Now, given this data, what is this data? This data is of 30 girls' heights in centimeters. We have to prepare a frequency distribution table. Say for example, 138 is the lowest height. 138 height is for two girls. So that is the frequency 2. Like that 139 is for one girl. Similarly, 160 is for two girls. So there are total 30 girls whose height frequency distribution table is derived from. Now, what are the important statistical distributions? We have binomial distribution, we have normal distribution, we have Poisson distribution, and we have the power law. Coming to binomial distribution, what are the properties of binomial distribution? They are discrete. They are sort of bell-shaped. Okay, they are defined using only two parameters. What binomial distribution do? They model the probability of occurrence of an event when a specific criteria are met. So binomial distribution involves following rules that must be present in the process in order to use the binomial probability formula. So what are those rules? Fixed number of trials, independent trials, fixed probability of success, two mutually exclusive outcomes. When we speak about two mutually exclusive outcomes, let us say we toss a coin. So when I toss a coin, so there will be two mutually exclusive outcomes. Either heads will come or tails will come. So the probability of obtaining a head is 0.5. Okay. So similarly, the probability of obtaining a tail is 0.5. Now let us say we do 50 trials. So the probability of head is 25. Because 50 multiplied to 0.5. Now, the formula for that probability is like this. P x of x is equal to ncx px qn minus x, where ncx is nothing but n factorial divided by x factorial multiplied by n minus x factorial. So this I derived from Srinik Jain's YouTube video, this formula, where n is the number of trials, x is the number of success desired, p is the probability of getting a success in one trial, q is equal to 1 minus p is the probability of getting failure in one trial. Okay, so let us take two numericals to connect with this. Let us remember the formula. What is the formula? P of x of x is equal to x is equal to ncx p to the power of x q n to the q to the power of n minus x. So, and which statistical distribution we are discussing? We are discussing the binomial distribution. We are understanding binomial distribution with the help of a simple numerical example. So let us say we have caused a coin 5 times. Okay, we have to find, using binomial distribution, the probability of exactly 2 heads or the probability of at least 4 heads. So how many number of trials are there here? 5. So the value of n is 5. What is the probability of head? That is 50%, 1 by 2. What is the probability of tail? That is 50%, 1 by 2. Now, how many heads I want? So let us look in the problem. Exactly 2 heads I want. So when exactly 2 heads I want, so the value of x is equal to 2. The value of x is equal to 2. And what is the formula being used? The formula being used is x is equal to ncx p to the power of x q n minus x. Now I know the value of n. What is the value of n? The value of n is 5. I know the value of x. What is the value of x? 2. So probability to the power of x, so that is 2. Q to the power of n minus x, that is 5 minus 2. So here ncx can be derived by using this n factorial divided by x factorial multiplied by n minus x factorial. What is the value of n? 5. What is the value of x? 2. So 5 factorial divided by 2 factorial multiplied by 5 minus 2 factorial, which is 3 factorial. Let us look at this example. Okay, x is equal to 2, 5 factorial divided by 2 factorial multiplied by 3 factorial multiplied by, what is next multiplied term? P to the power of x. So what is the value of x? 2. And what is p? So p is the probability of getting success in one trial. Probability of getting success is one trial. So how much is that probability? That is half. Okay, so that is half. So half to the power of 2 multiplied by half to the power of 3. Why this 3 is coming? Because n minus x, 5 minus 2 is equal to 3. So that is coming to be 5 by 16. Now, the next question is, we have to find the at least 4 heads using binomial distribution. The probability of at least 4 heads. So how do I get it? When I say at least 4 heads, I am saying x is greater than equal to 4. When I say x is greater than equal to 4, I am saying x is equal to 4 plus x is equal to 5. So I need to find the probability of x is equal to 4, then probability of x is equal to 5, then add them. So probability of x is equal to 4 is 5 factorial divided by 4 factorial into 1 factorial multiplied by half to the power of half into 4 into half into 1. So that's coming to be 5 by 32, and probability of x is equal to 5 is coming to be 1 by 32. So at least 4 heads is coming to be the addition of these two. Let us take one more example. 60% of the people purchase sports cars are men. So whosoever purchases sports cars, 60% of them are men. We have to find the probability that there are exactly 7 men if 10 sports cars are bought. Okay, so how many number of sports cars? 10. So the value of n is 10. What is the probability expected? 7. Okay, and what is the probability percentage? 60%, that is 0.6 success. And what is the failure? Then 1 minus 0.6, that is 0.4. Same thing we'll be using. Probability of x is equal to n factorial by n minus x factorial to x factorial p to the power of x q to the power of n minus x. So 10 factorial by 10 minus 7 factorial, 0.6 to the power of 7, 0.4 to the power of 3. That comes to be 0.215. So that was all about binomial distribution. So we are learning what? We are learning different important statistical distributions. Among them, the first one is binomial distribution. The second one is normal distribution. Let us look at normal distribution. What normal distribution says? It is also called as Gaussian distribution. It is a probability distribution, okay? And that probability distribution is symmetric about the mean, showing that the data near the mean are more frequent in occurrence than the data far from the mean. Okay, and this Gaussian distribution, this normal distribution appears like a bell curve. So if you can see here, this is a bell curve, this is a bell curve, right? This is a bell curve here, this is a bell curve, this is a bell curve here. So multiple examples were taken. As you can see here, I took this image from Investopedia, you have 68% of all values within one standard deviation. 60% of all values within one standard deviation. 90% of all values within two standard deviation. And 99% of all values within three standard deviation. Let us look at that. Okay. Where is that? Yeah, I can see here. 68% of the values or of the population are between are in the range minus 1 sigma to 1 sigma. 95% are in the range 2 sigma to minus 2 sigma. 99.7 are in the range 3 sigma to minus 3 sigma. This is also called as 3 sigma rule or empirical rule or 68, 95, 99.7 rule. What else we can speak about this normal distribution, this Gaussian distribution? The total area under the curve is 1. The two tails, these are the tails, they'll be extending to infinity. So let us say this is one tail and this is one tail. As you can see, I derived my image and content from digital e-learning. I have mentioned in the comment also, digital e-learning YouTube video. So these are the two tails which are extending to minus infinity and plus infinity. Minus infinity and plus infinity. What you are seeing here, this is the Z score. What is the Z score? You know, normalization value. So x minus mu by sigma. So here, wherever I see this is the central line, or this is the central line, or this is the central line, this central line is called as the mean line. And this distance is called as the standard deviation given by sigma. Okay. Say for example here, A and B are there. A is less than or equal to X, which is less than or equal to B. So the probability of any individual value is 0 here. This is the formula for a normal distribution or a Gaussian distribution. F of x is equal to 1 divided by sigma multiplied by square root of 2 pi multiplied by e to the power of minus x minus mu square divided by 2 sigma square. Okay. So f of x is probability density. Mu is mean. Sigma is standard deviation. Pi is the pi value. E is the base of the natural logarithm, which is approximately equal to 2.71828. So basically this formula defines the bell-shaped characteristics of the normal distribution. This bell-shaped curve is symmetric around the mean and its width is determined by the standard deviation. Let us come to the next statistical distribution called as Poisson distribution. Okay. So what Poisson distribution does, it finds the probability of an independent event that is occurring in a fixed interval of time and has a constant mean rate. Okay. So Poisson distribution is used to estimate how many times an event is likely to occur within the given period of time. So see here, number of phone calls per minute, this is the probability. So this is the probability of event in one interval. So this is about the Poisson statistical distribution. Coming to one more statistical distribution, it is called as the power law. It is also called as a scaling law. Okay. So what it indicates, relative change in one quantity results in a proportional relative change in another. Say for example, squares are there. Okay. If you double the length of a side, okay, the area will quadruple. Okay. So a power law distribution has the form y is equal to kx to the power of alpha, where alpha is the law's exponent, k is the constant, x and y are the variables of interest. The inverse relationship also is true, that is y is equal to x to the power of minus 1. This is also a power law because there will be a negative exponential change. Okay. So what is the use of a power law? Okay. It describes a small number of items are clustered at the top of the distribution or at the bottom, taking up 95% of the resources. For example, let us say rich people are there, billionaires are there. So there may be 5% of billionaires and 95% of the people who are not that rich. Okay, so this is all about statistical analysis. This is all about the four kinds of distribution: binomial, normal, Poisson, and power law. Thank you.